Exercise 1 through 5 contain a while loop and a predicate. In each case, show that if the predicate is true before entry to the loop, then it is also true after exit from the loop. Now, these directions are a little vague in my opinion because if this predicate is true, then that doesn't necessitate that the while condition is true. But in order to exit the while loop, you have to first enter the while loop. Now, just to be safe, I'm going to prove that this predicate is satisfied regardless of whether or not the initial while loop condition is satisfied. So just in case we need to clarify, I'm going to make this clarification. If the while loop condition is not met, then the while loop would be skipped. If the predicate is true before skipping the while loop, then the predicate will be true after skipping the while loop. And that's because if we're skipping the while loop, then these program lines don't really do anything because we're just going to skip the whole program and nothing about this predicate would change. And so the predicate would still be true because nothing happened. Now, from here on out, I'm not going to really discuss this possibility. For these while loops, we're only going to consider the circumstances in which the while loop condition is satisfied, meaning that we're assuming that the predicate is true before the while loop, and we're assuming that the condition of the while loop is also satisfied. So we have that m plus n equals 100, but we also have that 0 is less than or equal to m, which is less than or equal to 100. Now let's talk about what happens in this while loop. For each iteration of the while loop, m is redefined to be whatever m is plus 1, and n is redefined to be whatever n was plus 1. Think of this as like a new m and a new n. And each iteration of this while loop produces a new m and a new n. Now the new m plus the new n is equal to m plus 1 plus n minus 1. But if we simplify this algebraically, we just get m plus n. And according to this predicate here, m plus n is defined as 100 before the while loop. And so this is already true that m plus n equals 100. So the new m and the new n still equal 100. Now this is just one iteration of the while loop. After one iteration of the while loop, the predicate is going to be satisfied, that m plus n is still going to equal 100. It's going to be a different m and a different n after each iteration of this while loop, but this predicate will still be satisfied with each new definition of m and n, that the sum of the new m and the new n will still equal 100. Now, it's interesting to me about the verbiage of this question. The question is asking what happens after exit from the loop. Now, eventually we exit this loop, but when would we exit the loop? Well, m is increasing by 1 each iteration of the loop, and n is decreasing by 1 each iteration of the loop. Now, the only reason we could possibly exit the while loop is if m is either greater than 100 or it's less than 0. But each time we get a new m, but the way we get each new m is by taking the old m and adding 1, which makes the number larger. M is increasing after each iteration in this while loop. So that means m is going to keep increasing and keep increasing until we exit the while loop, because eventually m is less than or equal to 100 will no longer be true, because m is going to increase to 101. Now, what's important is that when m equals 101, then n is going to equal -1. And I know this because after each iteration of the while loop, the predicate is still satisfied, that m plus n is still going to equal 100. So when m no longer satisfies the condition of the while loop, it will be because m equals 101, which will then mean n equals -1. And so m plus n equals 100. And so the predicate is true at the end. But keep in mind, really, the predicate is true throughout the entire while loop, not just the end. Anyways, thanks everyone, and I'll see you in the next video.